Hello, welcome to my virtual tour of the Palo Seco mud volcano. Palo Seco mud volcano is located in southwest Trinidad near the village of Palo Seco at the end of James Trace. This map shows the location and distribution of mud volcanoes in onshore and offshore Trinidad. Many more mud volcanoes exist in the offshore than on land. On the left, the Kugler surface geology map indicates that the main structural element in the area is the southern anticline, which is made up of cruise age rocks with a core of what has been called the lower cruise clay pebble beds. Higgins and Saunders described the mud volcano as having an area of 0.5 hectares and about 75 meters in diameter. The pink dots indicate the mud vents mapped in the 1959 map, whereas the red dots indicate the May 2020 areas of activity. The topper map on the right illustrates the same thing. The little V's on the map indicate where mud volcanoes were mapped when the maps were done in 1977. This seismic interpretation from Pindell et al. Using 2D seismic from the onshore and offshore of Trinidad tries to explain the origin of mud volcanism along the southern anticline. Hydrocarbons generated from the Cretaceous source rock would migrate upwards along fractures associated with major faults that form the anticlines. Fluids and sediments from the formations through which the hydrocarbons are migrated are incorporated to form a buoyant plastic mass.
Good morning. Today we are at James Trace walking to the Palo Seco mud volcano. We are walking along a road that was originally built to drill a well called Apex Palo Seco 1 and 2. In the background we are hearing cicadas, more popularly called seagulls, which herald the approach of the rainy season. This path is very well maintained by the CPEP crew, and it's roughly a 10-minute walk to the mud volcanoes themselves.
This structural section shows that two wells, Apex Palo Seco 1 and 2, were drilled in the 1940s in the vicinity of the mud vents at Palo Seco. The lithology encountered is claystone with minor sands. This is similar to the coastal outcrops where most of the claystones are parallel laminated and individual sands range from 2 to 4 feet in thickness. Considerable difficulty was experienced in drilling Apex Palo Seco 1 due to the presence of mud flows near the surface. When mud weights were raised to control the mud, circulation was lost and the well had to be abandoned. Let's talk a little bit about the gases released by these mud volcanoes. Analysis at Palo Seco have indicated it is 97.3% methane, and there are no other gases that are harmful to humans. These gases burn with a yellow to orange smokeless flame and is odorless. Battiani et al. Indicate that this gas is of a thermogenic origin and high methane content is due to separation during migration. The little cartoon on the top left, attempts to explain this. Analysis of noble gas isotopes has shown that the residence time is shorter for the gas expelled by the mud volcanoes than for gas present in producing fields. Thus, gas expelled is not from the oil fields, but from deep kitchens. Analyses of water from Palo Seco indicate that the pH is 9.3 and it is not very saline. Analysis by Dia et al. In 1999 revealed that the unique methane content, the large positive oxygen 18 shifts, as well as boron, lithium, and barium contents revealed that the fluids originated at depths greater than 3 kilometers. These fluids, originally seawater, as they rise, mix with less deep reservoirs and meteoric waters. This suggests a recharge mechanism that contributes to mud expulsion. The water expelled is thus less saline than seawater. Castrec Ruel in 2002 indicated maximum age of water circulating in the mud volcano systems is plus or minus 9 million years. Kerr et al. In 1970 analyzed mud from Palo Seco and compared it with lower cruise samples. The clays are predominantly mixed layer alite montmorillonite and kaolite. The analysis basically shows that it's predominantly clay with some fine sand.
Here we have a palm that is called roseau, and it is covered by quite a number of thorns, so one needs to be very careful when walking into these areas that you don't get stuck.
This photo montage shows the location of the current active mud vents and pools.
We are now approaching the main pool.
The depth of this main pool exceeds 150 feet according to DeVille in 2002, and the mud temperature is slightly below atmospheric. The temperature profile shown on the right indicates that the temperature down the vent continues to be below the normal geothermal gradient due to cooling of the mud by gas expansion. This graph shows cyclic temperature changes within the Palo Seco mud volcano conduit over a half an hour period. Note the cold pulses are followed by thermal re-equilibrium tendency, and the cold pulses are interpreted as related to the cooling effect of expanding gas during the gas discharge. The only noticeable change has been that in the liquidity of the mud. In 2006, it was very foamy. In 2018, it appeared smaller, but even though the ground looks solid, it is dangerously soft. The number of active pools and vents are fairly constant, and there is no observable difference in activity between the wet and dry seasons, except for the number of mosquitoes.
ground along these vents is fairly soft, so it will be fairly dangerous to come to these mud volcanoes in the wet season because one may stick in these muds. This is the furthest south vent within the Palo Seco mud volcano complex. Note that the area around this vent is almost totally surrounded by bromeliads.